So we're going to do another one of these difficult cone questions. And we've got to show that the volume of our shape here is the same as the volume of the sphere. And the front of the book tells you that the volume of the sphere is 4/3 pi r cubed. And you can see that it's written bottom right there. And so let's do this. So they also, in the formula booklet, they tell you that the volume of a cone is 1/3 pi r squared h. Well, RH is r, so that makes it 1/3 pi r cubed. In the front of the booklet, okay, they also tell you, okay, here you can see the formula for a cylinder is pi r squared h. And again, RH is r, so this becomes just pi r cubed. So some of you might be able to sort of realize that you've got a whole pi r cubed here and 1/3 pi r cubed, so that's 4/3 pi r cubed. But I've written a formula here. So the cone is this one, the cylinder is that one, and if I factorize out the pi r cubed, I get 1/3 plus 1. And 1/3 plus 1 is 4/3, and therefore it's equal to the volume of the sphere, okay, which we have written up here. Now the next bit is a bit tricky, and it relies on the fact that, the tricky bit of it is that we don't know, okay, what this slant is. We don't know what this slant is, L. And for this next bit, we're going to have to figure out what L is, okay? Now, they do tell us that in this question, that the cylinder has formula 2 pi RH, okay? But you are also given that here in the booklet, surface area, curved surface area, I should say, of the cylinder. And they do the same for the cone, and you'll probably recognize that from last time. And so what I need to do is work out the total surface area of this shape, okay? Now, they've given us formulas for the difficult bits, but they haven't given you the one for the base, because they're hoping that you remember that this has, the area of this is just pi r squared. And so I get my cone, okay, which is pi rl given to us. I get my cylinder, which is 2 pi RH given to us, and the base, which is pi r squared. Now, as h is r, this cylinder just becomes 2 pi r squared, and the base is pi r squared. So the cylinder and the base, surface area-wise, gives you 3 pi r squared. But the tricky bit is, as I said, I mentioned earlier, is the L. Okay, and the L, I'm going to have to use Pythagoras. Okay, we knew that the height was r and the radius was r. This triangle comes from this triangle here. So what we have is pi r, and L turns out to be √2r. So the √2, if I put √2 r in there, you can see that the r and the r is going to give you the pi r squared that we had before, but with a √2 in front. So here I've got √2 pi r squared, 2 pi r squared, 1 r squared, and that gives me √2 and 2 and 1. If I put that into calculator, I get 4.41 and a bit more. But what I had to do was to show that this was more than the surface area of a sphere, which is, again, given to you in the formula with pi r squared. And we've done that because the surface area of a sphere is 4 pi r squared. We've shown it's 4.41 pi r squared. If you're interested, if you differentiate the formula for the volume, okay, multiplied by the original power, reduce the power by 1, you actually get the formula for the surface area.